higher order partial derivatives. Here we talk about the notation of the higher order partial derivatives, and then we'll compute the second order derivatives. And when you do the second order, you have mixed terms. We'll compute that as well. So the second partial derivative with respect to x of a function is denoted in three different ways that's listed here. Or the second partial derivative with respect to y is given in this form. And then the mixed partials, this is the partial with respect to y on the partial of f with respect to x. So basically it's the partial derivative of the function first with respect to y, and then on that equation you find the partial derivative with respect to x. And then you can flip it, the partial of the function with respect to x, and then on top of that you do the operation, the partial of the function with respect to y. We call numbers 3 and 4 the mixed second partials. The second mixed partials, f of xy, is the same as f of yx, and it just works itself out like that. So here we're going to find the 4 second partial derivatives. So the partial of z first with respect to x. So this is 4x to the third minus 6x y squared. Now we find the partial of z with respect to y. And so this is negative 6x squared times y plus 4y to the third. Now from these two we find the 4 second partial derivatives. So we find the partial of z with respect to x twice. So we look at this guy, because this is the partial with respect to x of the partial of z with respect to x. So this operation here operates on what's already been determined here. So this is 12x to the second minus 6y squared. The partial is this. This says you compute the partial of x on the partial of z with respect to y, and again these second mixed partials are the same. So for this one we take the partial that we found on x and we find its partial derivative with respect to y. And so this partial derivative with respect to y, 4x to the third is a constant, so this becomes negative 12xy. And what about here, the second partial of z with respect to y? We look at this guy and you find the partial derivative there again with respect to y. So this is negative 6x squared plus 12y squared. Find the partial of z with respect to y and then with respect to x. So we find this term here, we find its partial derivative with respect to x. This is negative 12xy, and that partial over here would be 0. With respect to x, the y cube is treated as a constant. And so you notice that this value and this one came out to be the same. And you also wanted to find this second partial and also this one here. Here in this exercise, show that the mixed partial derivatives there are all equal. So we look for the third partial derivatives. So this is the partial of f with respect to x. This is 2x minus 3y. Then the partial of f with respect to y is negative 3x plus 4z. Then the partial of f with respect to z is 4y plus 3z squared. Now we find the partial of f with respect to x, and then y, right? Because they want us to find that. So the partial of f with respect to x and then with y is negative 3. The partial of y with respect to x, we need that one, is negative 3. And then here the partial of f with respect to z, even though that one is not needed, and then with respect to y, it's not needed here for the combinations. These are just in terms of the x's and y's. So no need to find this guy, but I'll just find this one and then we go back. This is 6z. So now they want us to find the partial of x, f with respect to x. Then it says y, and then on this one, find this partial with respect to y. That's 0. And then we have the partial of f with respect to y, x. We have that one. And then you find that partial with respect to y. That's 0. Well, there was a combination that we didn't go down that road, so let's see if we can pick that one up. That is the partial of y, f with respect to y, again y, and then x. So we have the partial of f with respect to y. We found that one. So that's this guy here. Now we find that with respect to y again. So that's 0. And then obviously the partial of f with respect to y, y, and then anything after that doesn't matter. It's still going to give us 0. So they want you to find the partial of f, x, y, y. That's 0. Then the partial of f with respect to y, x, y. That's 0. And then the partial of f with respect to y, y, x. And it kind of sounds like the Wild Wild West. Thank you.